Hello everybody. In this lesson, we will learn how to use completing the square as a process of solving quadratic equations wherein the value of a is not equal to 1, or, in other words, a is greater than 1. Let us study the following examples. Find the roots of the quadratic equation, 2x squared minus 10x minus 3 equals 0. To solve this by completing the square, we have to place the constant term on the right side of the equation. To do that, we must add positive 3 on both sides. So we have 2x squared minus 10x equals 3. Before completing the square, we have to set the coefficient of the quadratic term to 1, so we have to factor out 2 on the left side of the equation. This will result to 2 times the difference of x squared and 5x is equal to 3, as it is reflected on the screen. The expression inside the parenthesis should be transformed into a perfect square trinomial by completing the square. To do that, we have to divide -5 by 2, square it, then add to the expression. So we must add -5 over 2 square on the expression inside the parenthesis. To make the equation balance, we have to add an expression on the right side of the equation. In this case, we have to add the expression 2 times the square of -5 over 2 to the right side of the equation. The number 2 is the value of a in the quadratic expression, and the square of -5 over 2 is the expression added to make the quadratic expression inside the parenthesis a perfect square trinomial. This process is true in solving all quadratic equations by completing the square, where the value of a is greater than 1. The next step that we should do is to express the quadratic expression as a square of binomial. We have to simplify also the expressions on the right side of the equation. As you can see on the screen, we have 2 times the square of x minus 5 over 2 equals 3 plus the product of 2 times 25 over 4. Then we have 2 times the square of x minus 5 over 2 equals 3 plus 25 over 2. That is by simplifying 2 times 25 over 4. Then we have 2 times the square of x minus 5 over 2 equals 6 over 2 plus 25 over 2. We should make the terms in the right side of the equation similar fractions to get their sum. Then we have 2 times the square of x minus 5 over 2 equals 31 over 2. Then we have to isolate the variable x on the right side of the equation. To do that, first, we have to multiply both sides of the equation by 1/2. Then we have x minus 5 over 2 square equals 31 over 4. The next step that we should do is to get the square root of both sides. These will result to x minus 5 over 2 equals positive and negative square root of 31 over 2. The next step that we should do is to add positive 5 over 2 to both sides of the equation. This will result to x equals 5 over 2 plus and minus square root of 31 over 2. Therefore, the roots of the quadratic equation, 2x squared minus 10x minus 3 equals 0 are, x equals 5 plus the square root of 31 over 2. And x equals 5 minus the square root of 31 over 2. The roots are two irrational and unequal roots. Let us study the next example. Find the roots of the quadratic equation, 3x squared plus 5x plus 1 equals 0. By addition property of equality, adding both sides by -1 will give us 3x squared plus 5x equals -1. If we factor out 3 on the left side of the equation, we get 3 times x squared plus 5 over 3x equals -1. To make the quadratic expression inside the parenthesis a perfect square trinomial, we have to multiply 1/2 with the coefficient of x, square it, then add to the expression. In this case, we add 5/6 squared to the expression inside the parenthesis. The term to be added to the right side is 3 times the square of 5/6. Express the quadratic expression at the right side as square of binomial and simplify the right side of the equation. This results to 3 times the square of x plus 5/6, equals -1 plus 3 times 25/36. Then we have 3 times the square of x plus 5/6, equals -1 plus 25/12. Make the terms in the right side of the equation as similar fractions, then add to have 3 times the square of x plus 5/6, equals 13/12. Multiplying both sides of the equation by 1/3, we get x plus 5/6 square, equals 13/36. Then get the square root of both sides. This will give us x plus 5/6, equals plus or minus square root of 13/6. 6 came from the square root of 36. Adding both sides by -5/6 will give us x equals -5/6, plus or minus the square root of 13/6. From this, we can derive the roots of the quadratic equation 3x squared, plus 5x, plus 1 equals 0. The roots are, x equals negative plus the square root of 13/6, and x equals -5 minus the square root of 13/6. There are two irrational and unequal roots. Those are some examples on how to solve quadratic equations by completing the square given the value of a is not equal to 1. There are other problems with solutions available in the gallery below for you to study. Thank you very much.